All right, I think now we can get started. There's a few people who have joined in. So today I wanted to kind of go through just an understanding of what is a stack. And before we do that, I just wanted to recap what we did in the last lecture. Just to tell you all who are joining new as well, we have all the lectures we're putting it on YouTube channel. It's channel is shared on the WhatsApp group as well. So you can look at the last few lectures as well. To get an understanding of the basic data structures. Just to recap, what we covered in the last lecture was an introduction to linked list, a very brief idea of what is a linked list. We defined a linked list. We did some operations on them, like printing, addition, appending, insert, and tried to do a delete. I think insert was something we skipped, and we did append and delete. And we also solved a problem using linked list, which is basically like the reversal of the linked list, right? Which is a very commonly used asked question in interviews as well. So this is a very brief idea of what these data structures are. Today, what I wanted to do was just cover stacks as the next data structure. And in stacks, essentially the subtopics that we want to cover is essentially what is a stack. We'll try to visualize what are the semantics of a stack. What are the interfaces of a stack? So what are the basic functions that need to be there for a stack to be present and be well defined? And then we'll go into the implementation mode and like create a stack using Python. And what is interesting is stack is an implementation that uses linked list. So whatever knowledge we gained in the last lecture or the last session, we'll use that to build a stack just on top of it. And we'll do an interview problem. I picked the most simplest problem that is usually asked, which is like reversing a string with the stack. It's pretty simple. You can cover it in this session. There are more complex problems that I'll share on the channel that you all can try out as well. And if there are any doubts, we can do a doubt session as well around it. So stacks have very complex questions that can come in. But this is a very brief idea of what a stack is. So so what are the semantics of a stack? Essentially, the semantics that a stack exposes is a last in first out semantic. In short, we call it like a LIFO. So essentially, what do we mean by LIFO? I'll try to define that. So if you want to visualize stack, the way one could visualize is a stack has a head that is present, and a stack has a you can say a base or the end of the stack, right? And so the top of the stack is pretty much the head, from where the inserts happen, as well as from where the pops or the or push out of the a pop of the stack happens. So essentially, if you want to get any data out of the stack, you take it out of the head and you push it into the head as well. So let's say if this is the current state of the stack, X, Y, Z, A, and phi, you can access, if you want to add a new element, let's say we want to add a new element W, it will get added to the top of the stack. So the W gets added to the top of the stack. And if you want to access any element, you can just access W by calling this interface called pop, right? And we'll define the interface later, but the semantics essentially are that whatever you've pushed at the last will get pulled out the first. So that's where it kind of differs from Q, and Q will cover in the next session. Wherein Qs are FIFO. So whatever goes in first comes out first, right? So that's where it's a little different, and they have different use cases, and that's why these core or basic data structures have been designed and defined, right? So one would ask, what are the basic interfaces that need to be implemented in a data structure for it to become a stack data structure? So there are 4 basic interfaces that we need to implement for a data structure to be a stack. So first is the init. So the init method essentially is a method that initializes a stack structure as an empty data structure. So it basically creates this stack with phi in it, which is empty. And we'll also go through a case by case or a scenario where we use all these methods to visualize it better, right? So init is one. And the next is an IsEmpty method, which is basically just trying to say whether the stack contains an element or not, right? If it's empty, which means it doesn't contain anything, that is, it just contains 5, right? Otherwise it returns false. And then there are two methods, which are the access methods, so the push and the pop, right? So the push method essentially takes in an element. The element could be string, it could be an integer, could be double, float, etc., and pushes it on the and keeps it on the top of the stack, right? And the next element or the next interface is the pop interface. So the pop interface's main responsibility is to get the element which is present at the top of the stack out. One of the interesting things is that the pop interface, if executed on an empty stack, will return an error or raise an exception. And the idea is that if the stack is empty, then the pop cannot return anything. And if you're looking to return a string, and if there is nothing, then it will basically raise an exception. That's just by definition how the stack data structure is designed, right? So that is the idea. These are the four basic methods, and any other operation on stack could be done using those. So you can implement like a peek method, which tries to look at the second or the third element, and you can do it through a combination of pushes and pops. But if you know these four interfaces, you can do anything with the stack. So that is the idea, and you need to very well understand these four interfaces. So let's try to take a sequence of actions to be able to understand, visualize, and get to a better understanding of what exactly are we doing with these, right? So let's say you do an init on a stack. You then check an IsEmpty method. You push X, which is a string that you're trying to push. You then check again IsEmpty, and then you pop, right? So if let's say you did these operations, what would end up happening? So like an easy way to visualize would be that you would have an empty stack after init, this is pretty much the step 1, right? And this would be the step 5. So you can imagine it like this. This is how it's kind of proceeding. So when you call init, an empty stack with 5 will get initialized. Then we'll ask or implement, like we'll call the method IsEmpty. It is empty, and so thereby we'll return a true on the stack, right? Then you will push X. So what will happen is that the stack will get allocated a node, and the node value will be X, right? It will be allocated at the top of the stack. And then you will call IsEmpty. This will return false because now the stack has X on top of it. You will call pop, and pop will essentially pull out X from the top. And you can see that after you call pop, it not only returns the variable which is, or the value which is at the top of the stack, it also empties the stack. So it also kind of deletes that node that was present at the top of the stack. So that is an important thing to know as well, that it changes. So it's a mutating operation. So it changes the size of the stack as well, right? So that's important to know. And thereby when you call pop on an empty stack, it can't mutate anything, and thereby raise an alarm or an exception, right? So that's pretty much it from the interfaces. Very, very basic, simple interfaces, but you need to have a good understanding of how these interfaces are implemented, right? So now let's go to, let me just, okay. So let me just go to this other screen where I have the code, right? So I'll quickly go into, now we'll try to think about how do you kind of implement a stack and how you solve problems using a stack. Any questions that you have, feel free to add it in the chat window. We'll try to answer those at the end, right? So here, I think what I want to do is just introduce this and just go through what we did in the last lecture. And this is a more simplified version of a linked list, where what we did was we built a linked list. We built a node object, which is part of the linked list, which has a data and a next, right? That's what we kind of built in the last tutorial. And then we had built this linked list, and we built a few methods in it. So we built an init method in it. We built an IsEmpty method. So it verifies if the list is empty. The same with stack. We built this insert method, which pushes data at the front of the list. And we also built this get first and delete first methods. So the get first method will basically get the first element that is present at the front of the list. And the delete first method will basically kind of delete the element from the, which is at the front of the list. And if you have any doubts, we can also go through these again to explain it much better. But essentially, this is what we built. And why are we doing this or reviewing this is that stack is a data structure that is built on top of a linked list. So that's why we are trying to do this, right? So let's try to build a stack from a base. So I'll try to just so test. So yeah, I'll just code it up and then we can do it simultaneously. And I'll try to explain what I'm kind of thinking while building it, right? So essentially, firstly, what we need to do is we need to import the linked list class from the linked list file. So the way you kind of import anything in Python is we would, yeah, this is fine. So we basically say that from the linked list file .py, you could import the class called linked list. So essentially file name and the class name are the same here. But essentially this means from file import the class, right? So that's what we ended up doing. And then we'll define a stack class. So to define a stack class, we'll first define the basic init method. This is just Python semantics. So you basically define the init method. And within this, what we'll do is we'll say that I want to use a linked list to do that, because otherwise I'll have to implement all the methods of keeping a node in a data structure, looking at a node and deleting a node and pushing a node. So those are things I don't want to do. I just want to look at the old, look at the linked lists implementation, use that. So let's define isEmpty. IsEmpty is, should be pretty simple to define in this case. So what isEmpty would say would be just check if the list is empty, right? And this should be good enough. What this will do is it will take a look at the list, and if the list has no elements, it will return true, otherwise it will return false. So pretty basic. Then we said init we've already defined. Then other two methods, which is a push method. So in a push method, you need some data to be pushed, right? So it's basically kind of doing that. And then we'll define this pop method. So let me just mark this thing, otherwise it kind of runs into other issues of indentation, right? So we'll do this push method. So in the push, basically what you need to do is you need to add the element at the top of the stack, right? So this also should be pretty simple. When what we'll say is we'll say in the list, you basically insert the data, right? And let's look at the insert semantics. So what we said was that it'll insert data at the front of the list. So this is all we need here, right? We just need to insert the element at the front of the list. And you can also write return. Usually it's not necessary, but it's fine. In pop, there is an interesting part of it that we need to know. Is essentially you need to also check whether the list is empty or not, right? So if, let's say, if the list, sorry, or if basically the stack was empty, which can be checked like this, right? Which basically saying if the stack is empty, and this is pretty much how you kind of do basic programming, is you would have to ensure that you check the base conditions, edge conditions. So if you are very comfortable with that, you'll first check whether like the data structure is empty, whether the algorithm is hitting the edge cases. You first try to check those. Once those you have checked, then you can implement the basic method, right? So that's what I'm trying to do. I'm trying to check if the list is empty, then I can't do much, right? It's an illegal operation. So when there's an illegal operation, I'll try to raise an alarm, right? In this case, this is an exception. And this is basically part of exception handling. And the idea is that we'll do a session on how exceptions are handled. But essentially, the idea is that the program will stop here and raise an exception. If so, this is how it is done in Python. And then if, let's say, the exception that if the stack was not empty, this is the happy path. This is easier to implement. What we need to do is we need to do two things, right? So when we are kind of coding, just ensure that you understand each of the steps in your mind very clearly. So the two things that you need to do is you need to first, and sometimes I do this, sometimes I basically write it down in a way helps me just visualize is the steps are get value, right? And then there are three steps: delete, node, and then return value. So sometimes if there's a complex algorithm, you kind of break it down, write the comments, especially in interviews, it kind of helps a lot because now you can easily think in isolation. So how do you get value? So you can get value by saying, I'll create a variable non-named value. I'll get the um, first get first, right? So get first will get me the first element from the linked list. So that's the idea here. And then what I'll do is I'll also delete the element. So there's a delete first as well. So delete first is what I need to call, right? And the other thing here is that now you've already checked this condition, so you don't need to worry about whether the list is empty or not, right? So that is pretty much the idea. And then I'll return the value. So pretty basic, but yeah, it should now return the value. And this I think is not good. This should be okay. Right, so this is pretty much what I've done. So we've implemented an init method, an isEmpty method, a push and a pop method, and then this should be good enough. Now let's try to write a test case, right, for this particular. So in the test case, what I want to do is I want to eventually do the same thing that we did in the sequence of actions that we took, right? So I'll first do print, I'll first check. So that's fine. Yeah, I'll first check whether the list is empty. And you'll see that the operations and the print statements converge, right? So I'll first check if this is empty, and the way, right? So, and what I'll do is I'll create an empty stack and then run the test on this. Just a way to kind of test out whether the methods that we've written are right or not, right? So this is fine. Then what I'll do is I'll push on the stack. I'll push X, right, and then on the and then I'll print again if the stack is empty. And this time, right, this time we should not get this empty. And then what I'll do is I'll pop. And I'll again print whether the stack is empty or not, right? So this will give us an idea whether the methods that we've implemented, are they right or not. And here I will try to also print, right, let me just print here. And let me just print here. So when you get a value, you can also do something like this, where So the way to like one of the things that we did here was that we also concatenate strings. So the way to print is to have concatenated strings is to have the string variable and then add a plus in between. So that will just concatenate the string and print this string, the string one, and then the output of the string. Right. This is what it should do, and so we should be good now. So what we've done is that we've written a test wherein in the test we'll first test whether the stack is empty. Then we'll try to push X, we'll push it, and then we'll try to see if it is empty. If it is empty, then we'll pop. And after that, we'll check whether the string is empty, whether the stack is empty or not. Right. So let's try to run this. Right. There's an indentation error, I think. Yeah. So I'm just fixing this. Okay. 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 So initially, I think it was empty. Then we pushed X, and the stack became false. So empty became false, right? Then we said popping value, and the value that was popped essentially was X. So run it again, and then isEmpty became true, right? So basically, we kind of tested out whether the basic operations that we've defined on the stack, do they work or not, right? And you can see that once you layer the stack on top of linked list, your implementations become very, very easy, right? Now, I mean, here we didn't have to do much. We just had to implement this pop method, and the rest of the methods became easy. So the idea essentially is that whenever you're asked a question and a problem that has this LIFO semantics, right? So wherein you need to look at the last element that was pushed in. So that sometimes, like some of the examples that come to mind are, for example, if you need to check brackets, right? So in a program, sometimes we need to check whether the brackets are in a program, whether the brackets match or not. So the open curly braces and the closed curly braces, do they match or not? That is implemented through a stack in a compiler. And the reason is that the closed bracket has to look at the last open bracket, right? So you need to kind of keep pushing the open brackets and then push the closed bracket. Whenever you push the closed bracket, you remove off one of the open brackets. So there are LIFO semantics that are there in that kind of a problem, and you need to implement stack. So if you get that intuition out, right, you can quickly like use a stack to implement it, right? So that's one of the ideas. One of the other problems that is commonly asked is this problem of basically reversing using a stack. So we'll also do that problem in this session. So I just call it reverse string dot py, and you'll see it's pretty easy kind of to implement the reverse string using a stack. But the only intuition that you need to build is that the reverse string is essentially a program that uses a stack. So building that is important. And I'll give you how I kind of build that intuition. Let's first write this down and see if it works, and then we'll try to see how we could build that. So essentially, reverse a string, and the way I'm defining it is essentially first I'll import. So from stack underscore test, stack import stack. So I already had an implementation of stack, so you can just use that. And we'll say I want to reverse a string. We can actually use this as well. Should not really matter much. So how do you reverse a string, right? So given a string, any string, what you will do is you would first in this the idea of string reversal is let me just open this up. So this might be better to look at. So here, this you should be able to see, right? So if you think about string reversal, right, I'm trying to share the intuition. So let's say the string is XYZ that we need to reverse, and what you need to give as the output is essentially Z, Y, and X, right? So that is a reversal. And so essentially, if you imagine, what you could do is you could say that we'll take each element of the string and push it in a manner that the last element becomes the first element that we need to access, right? Because when you reverse, the last element becomes the first element, right? So this is pretty much the core of the intuition if you think about it, that a reversal operation is an operation where the last element becomes the first, the second last becomes the second, and the first becomes the last. So even if you get this you can quickly relate with the LIFO semantics, which you can quickly relate to the stack. So if you run this in your head, right, what will happen is you will have an empty stack. You will keep pushing X, Y, Z, right? So here this should be a 5, which is okay. And then you will push X, Y, Z. And once you're done with this, then what you'll do is you will start to pull it out. So you'll pull out Z and then Y and then X. So this is the push operation the push operation state, and this is pretty much the pop operation state, right? Actually the direction should be this. So say the direction is this, otherwise it might get confusing, but essentially pop is this. So once you get this intuition out, right? So if you're being asked in an interview, even if you just draw this out, that will give you enough idea of how to implement it, and then coding becomes like a easier part of out of it, right? So let's just implement this idea in a code using the stack. And in an interview, you can just assume that there is a stack library function that is available. You can just write this reverse. Even that is fine. You probably don't need to completely implement stack. So the way you would first do it, you would need to know the length of the string, because if you don't know, then how do you eventually know how to iterate over the elements of the string and how long to iterate? Use a stack. We'll use a stack variable or a stack element, and then we'll iterate. So for I in So it will be 1 to n. Sorry, it should be from 0 to n at loop of 1. Right. So, and then we will create we for each element we just push it into the stack. Right. So just push it using string. So essentially this is the push phase. I just implement the push phase, and then let's do the pop phase. So the way I'm thinking about it is that I will keep everything in a string. So I'm keeping an empty string, and I'll again go through. So let me just I'll go through it again, and what I'll do is I'll say bstr. I'll keep appending to the string. This is not pop. So eventually every element from the top of the stack will get appended to the string. So this is an append operation in a string. It's pretty basic. And then you could say return str. So yeah, that should be good enough. I just want to check quickly if the this is correct. Right? Otherwise, we'll complain. I didn't think, yeah. So that's what I meant. Yeah, otherwise it would have thrown an error. So this should be, I think, good enough. So what we did, we said we'll try to do reversal. To do the reversal, we need to figure out the length, create a stack, create an empty string because this is the placeholder. Have a push phase implementation, have a pop phase implementation, return it, right? And let's try to see if this works. So let's say S is the string, which is equal to X. Yeah, the example I was trying to use was, let's use XYZ, and then we should say print. So reverse is equal to, sorry, reverse. Okay, so just going through it, I just try to sometimes do a dry run so that I haven't made any mistake, and let's try to run it right. Okay, so yeah, I think the only trouble was that I think we have this on as well. Yeah, I'll do this as well. So, okay, so essentially we ran the reverse, and so it basically printed reverse of XYZ, ZYX, right? So essentially it worked fine. You can do a little more testing as well. If you say X, usually good to do this so that there are no bugs in this code, right? Empty should not raise an alarm. So yeah, reverse it's empty. So it's pretty much fine. So this is how you would do a reversal of a string. I hope this kind of gave you a good idea of implementing using stack, so you will not get too stuck on when you are asked a stack question. And in an interview, you will not be asked a stack question by ask, like in a way wherein the interviewer will say reverse a string using stack. They'll just say reverse a string, and then you have to understand that this probably is a stack question and use it. You can do reversals in other ways as well, but like a stack is a good way to do it, right? It's a very pretty simple way. So the question that was asked was around the ray syntax, right? So the idea is that essentially that if there is an exception that needs to be raised or an exception that is there, you basically in the syntactic way you can just say raise, or eventually you could also give you can like give a string with a raise, and that string will get also printed out, right? You can also do that, but the idea is that the program here will end and it will basically raise an exception, and the exception will get thrown above, right? I completely don't remember the syntax, so I'll have to check it out, but I think in general you can save the command with the string name, and the string will basically be the error message. So essentially an error will have a code and a message. So you can print like the code with it. So it will just raise that. I think we can try it, but actually I haven't tried it before, so can probably it's okay. So I'll give it a shot and let's see if it works. Otherwise, we can look at the syntax on the web as well. But the idea is that like you raise an exception, you print a string with it, and the string is used for debugging. So that's pretty much the basic idea across all languages. So let's say if you didn't do this push, right, it will start raising exception and empty. Stack. But yeah, I mean, my whole objective is to kind of give you the idea of the fundamentals. So, right, it raise an exception. Yeah, it's probably not the right. I'll check it and get back to you. But the idea is that the exception could be raised with the you can raise an exception. The program execution will halt. So let's just do that. That we can definitely test. It should halt and it should throw something out, right? So yeah, I mean the program execution did halt. Actually, let's just check. So yeah. So yeah. So, yeah, I think you would have to give a. Let's try it out. So simply. Uh, so the question is, can we print stack is empty? I think that the problem is that what do you return, right? Because the semantics of this method would be to return a string, and then the client will expect it to return a string. You can return an empty string for this case, but not all objects can be empty, right? So there can be problems with that. For example, if you're returning an integer, what do you return in that case? So that's why you definitely need to raise an exception. That's pretty much the semantics as I understand it. And then, yeah, so it will raise an exception, which is empty stack. So yeah, thanks Dhanush for the input, which makes sense. So pretty much this is how you end up raising search. I also checked on the internet, so to be honest, right? I didn't know exactly the syntax. But in general, I think to understand, become a good programmer, in general, my rule of thumb is that don't like get tied to too many kind of remember all the syntax, because it's very hard to remember all the possible syntaxes. Not a lot of new languages come in, but just try to understand the basics and fundamentals of why like exceptions are raised, how do you catch exceptions, when to raise and when not to raise exception, when it is definitely required, when it could be avoided. Like those kind of things are more important in my understanding. And sometimes, like even in an interview, when do an interview, I usually ask people to write pseudocode. I don't even marry them to a specific language, because if you know the basics, they can learn like language from like Stack Overflow and while coding, right? So that is not really a problem in my head at least. Yeah, but it could be just my personal choice. But anyway, so I think the objective of this whole tutorial was just this, that we look at stacks, we look at the basics of stacks, and we also understand the intuitions behind it. In this particular whole series, I just wanted to do very simple data structures. I'll try to do more complex ones and more complex in another kind of series and upload those videos to it. So any other questions, if you have anything that you wanted to ask, any feedback from me, feel free to give me feedback as well. That will also help me improve these sessions, and hope these sessions help you out as well. Yeah, if you want to speak, you can speak using this unmute. If you, yeah. Otherwise, this is what I had for today. So I'll kind of close it out. It was a short session. Okay. Yeah. Okay. Okay. and I'm just in this like whole series I'm using Python. But Python is kind of easy to execute on. Like even in interviews, I've seen people who use Python. They're quickly able to write the program and discuss other things. You can use C, C++, Java, so it takes a little more time. So that's why I'm been using Python. But the concepts are independent of the language. So that's pretty much what is important to understand, what you usually get judged on. There are some interviews that are very language specific, but in general, uh, uh, like good companies usually have interviews which are language independent. So that you can keep in mind. Okay, I think that was it mostly for today. Any feedback you can also give on the WhatsApp channel, and I'll keep posting some of the questions as well. So that I need to do. What I'm trying to do is have a very simple portal on which I can post questions and you can try them out as well. So that way you'll get more used to these concepts if you're learning them during this period of time. Okay, thank you so much for joining in. Yeah, I can call it a meeting now.